In today's lesson, we're going to be looking at transformations of quadratics in vertex form. So what we're going to start off with here is this is referred to as our parent function. So given a quadratic, when you talk about transformations, they'll use the term parent relation or parent function. And it's kind of like your base, right, where you're starting off. And all the other transformations that we do will be referring to our base parent relation here. So let's take a look at our first question here. So number 2 here, if you take a look, we have x minus 2 quantity squared. So we want to talk about how is that going to affect the way our base relation looks, right? Again, this is our base relation. This is y equals x squared. I want to graph this and see how it is related. So if I were to let x be 0 into this expression, if I let x be 0, that would output a 4. So I'd be right here. If I let x be a 1, that would output a 1. You'd have negative 1 quantity squared. If I let x be 2 this time, we actually would get a 0 on this. If I let x be 3, 3 minus 2, quantity squared is 1. And lastly, if I let x be 4, we would output a 4. So connecting these points together, we see our parabola is now shifted over. The parabola is shifted 2 units to the right. So you'll notice here, comparing our parent function and our translated quadratic, we can see we've shifted every point over exactly 2 units to the right-hand side. This has a term, and this would be referred to as a horizontal shift, and then you'd say 2 units to the right. Typically, we can abbreviate horizontal shift with just an HS in the future. Okay, let's take a look at number 3 here and see how that's going to adjust things. So again, we have our parent function, right? Y equals x squared. I want to graph x plus 2 this time, quantity squared, and see what happens. Well, let's go ahead and do the same thing. If I let x be 0, it's going to output a 4. If I let x be a negative 1 here, it's going to output a 1. This time, if I let x be negative 2, I get a 0. If I let x be negative 3, it outputs a positive 1 because you're squaring that term. And lastly, if I let x be a negative 4, it's going to output a 4. So connecting these up here, you can see that now we have our translated quadratic, and now it has moved exactly 2 units to the left. So what we have this time is a horizontal shift 2 units to the left-hand side. Okay, so now we can see here with this, right, we can see now when you compare x plus 2 quantity squared to your parent function, now this results in a shift of 2 units to the left. All right, let's take a look at number 4 here. So same idea, you can probably guess what's going to happen. Based on the 2 examples we've seen, I would probably guess that what we're going to experience here is a shift of 3 units to the left-hand side, every single one of these points. So let's see what happens. Now, if I let x be a 0 here, you're going to have 3 squared is 9, and that's off the graph. So we're going to go to the left-hand side and see what happens. If I let x be a negative 1, that's going to output a 4. If I let x be negative 2, that's going to output a 1. If I let x be negative 3, we get a 0, negative 4, a 1, and if I let x be negative 5, we output a 4. So you'll see here, connecting this up here, now what's resulted is a shift 3 units to the left. So using our terminology, this would be a horizontal shift 3 units to the left-hand side. So you can see here, you're essentially you're switching the sign in the brackets, and that illustrates the shift that you're going to do. And x plus 3 would result in 3 to the left. A positive 2 is 2 to the left, and then a minus 2 is 2 to the right. Had this been a minus 3, we'd be shifting the quadratic 3 units to the right-hand side. So these 3 examples here are examples of horizontal shifts or transformations of your parent function, parent relation, y equals x squared. Okay, let's see what other types of transformations you can do to your quadratic. Okay, take a look at number 5 here. Again, we have y equals x squared. What happens to our quadratic if we just add 3 to the end of our parent function? Well, let's pick some values and sub it in and see. If I let x be 0 here, it's going to output a 3 this time, not a 0. If I let x be a 1, it's not going to output a 1, it's actually output a 4. Likewise, if I put it in a negative 1, it's going to output a 4. And if I let x be 2, it's not going to output 4, it's going to output 7. So this will be another 7 up, and then here, 7 up. And you can see what you have is a quadratic, exact same quadratic, just shifted 3 units up. So now what we have here is we have a vertical shift is the term that's used here. And they refer to this as a vertical shift. Right, so vertical shift, which again we're going to abbreviate with a VS. And in this case, it's 3 units up. Vertical shift 3 units up. Okay, so you have another type of transformation going on here. Now we're shifting the parabola upwards. Likewise, you can probably guess how is the parabola going to be affected by x squared minus 2. Well, every one of these points is going to now go down 2 units. Down 2 units. Down 2 units. Down 2 units, and down 2 units. So when we connect up this parabola here, you can see we now have a parabola that shifted down 2 units. So this would be a vertical shift 2 units down. And now we have our quadratic shifted 2 units down. Okay, and the reason for that, you can see, the reason that why that's working is you're taking your parent function and you're just subtracting 2 to each of the outputs. Okay, so these two examples here, these are examples of vertical shifts. So we have horizontal shifts going left and right, and we have vertical shifts going up and down. Notice the vertical shifts, there's not a sign change on this. You just add 3 means you go up. Subtract 2 means the parabola is shifted down. Whereas these here, a positive 3 is 3 to the left, and a negative 2 or a negative 3 would be 3 to the right, or 2 to the right. Okay, let's take a look here at mixing these two together. So now we've got a combination of operations here. So what is this going to do? Well, let's write down what transformations we know. I know that what I have in the brackets is going to result in a horizontal shift, 1 to the left. And I also know that what I have here is going to result in a vertical shift, 2 down. So that means what we do is we take each of our points and we apply this transformation to them. Now it's very important to remember, and this is a key thing here, when you're doing your transformations, you have to follow the operations of bed mass. So that means what I have to do first is my first transformation has to be in the brackets. So which means I do my horizontal transformation first, then I move on and do my vertical transformation. So every one of these points, you're going to go 1 to the left and 2 down. So 1 left, 2 down, plot a point, 1 to the left, 2 down, 1 to the left, 2 down, 1 to the left, 2 down, and 1 to the left, 2 down. You can see here, within no time, you have a decent sketch of your translated parabola. Notice here, this is my vertex. We've already studied vertex form. If you're unfamiliar with vertex form, I'll put a link up in the top right-hand corner. But the vertex of this parabola, right here, the vertex of this parabola is -1, -2, and that's exactly what this point here is. This is the vertex -1, -2. Okay, let's try it with this one here. Same idea. Write down your transformations. So my transformation here, we're going to have here I'll write it down here. We're going to have a horizontal shift, 3 to the right. And then you're going to have a vertical shift, 1 unit up. And again, when you're working with these, you're going to take care of brackets first. So I'm going to do my horizontal shift first. So every one of these points, you're going to go 3 units to the right and then 1 up. 3 units to the right. So 1, 2, 3, and 1 up. 3 units to the right. So I'm going to transform this point now. So 1, 2, 3, 1 up. Let's move this point here. So it's going to go 1, 2, 3, 1 up. And lastly, 1, 2, 3, 1 up. Connecting these up here, we have our translated quadratic. The vertex here we can see is 3 over 1 up, which is exactly what we would have gotten if we just read it right from our vertex form. And we have our translated quadratic. Okay, let's take a look at number 9 here. So for number 9, we're looking at it's a different translation. The translation for number 9 is we're taking our normal parent function and we're just multiplying it by 2. Multiplying the output by 2. So you're doubling your output. So let's see what would happen with our quadratic here in number 9. The output here is 0 for this point right here, so it's unchanged. If I take a look here at my point right here, if I'm going to double that, that's going to go up to 2. Likewise, if I look at this point here, this is at 4. It's going to go up to 8. So here I'm at 1, 2, 3, 4, 5, 6, 7, 8, right to the top. And likewise, this point will be doubled, and this point will be doubled. So when I connect up my parabola in this situation, you can see here what you have is a parabola that's typically viewed, people use the term thinner, right? The parabola looks a little thinner. And the correct terminology here is we would refer to this as a vertical stretch by 2. That would be referred to as a vertical stretch by a factor of 2. And the idea here is you're stretching it in the y-axis, i.e. it's in the vertical direction, by a factor of 2, and you're doubling that idea. Okay. Now, let's take a look at number 10. Now, instead of putting a 2 in front, how will a half affect the result? Well, if I take 0 and multiply by a half, it's still 0. However, if I take 1 and multiply it by a half, it's a half. This would also be a half on this side. If I take 4 and cut that in half, you're down to 2. And obviously on the other side, we're also down to 2. So what you have here is a parabola that is a lot wider. The correct terminology here is we will refer to this as a vertical compression. And now you wouldn't say by a half, you would say by 2. And the reason for that is you're compressing it by 2. You're cutting down each point by 2 in terms of its distance to the x-axis here. So what we have here is this is a vertical compression, and this right here would be a vertical stretch. Okay, so we can already start to make conjectures on these a values. Obviously, if this was a 3, it would be even thinner, and if this was a third, it would be even wider, compressed even more towards the x-axis. Okay, let's take a look here. Now, what happens if we take our normal translation, parent function, multiply it by 2, so we already know it's going to be a vertical stretch, but then multiply by a minus sign as well. When you do that, it's the same way you would tackle these problems here. You're going to go ahead and multiply the output by -2. So if I multiply 0 by -2, that is unchanged. If I multiply 1 by -2, it's going to go down here to -2. If I multiply 1 by -2, it's going to go down. If you take a look here, I'm up to 4 units off the x-axis. If I multiply that by -2, it's going to be all the way down to -8. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8. And likewise, on the other side, you also get a -8. So connecting this up here, you obviously have your stretch by a factor of 2. You can see it's a thinner quadratic. And also, it is reflected, and they use this term, it's reflected in our x-axis here. All right, so there's a new terminology here that we're going to use. We still have a vertical stretch by a factor of 2. So we still have that's happening to this quadratic, but the second thing that's happening is a reflection in the x-axis, you would say. Right? Every one of these points is reflected in the x-axis, Now I'm using the term reflection, i.e. it's a mirror image, but it's reflected in the x-axis compared to your y equals x squared function, y equals 2x squared relation. But at any rate, it's a flip. Sometimes they use the term flip too in your x-axis. Okay, let's take care of number 12 here. Take a look here. So if I'm looking at number 12, again, we have a couple of operations going on here. First of all, what do you do first? If we're going to follow our bed mass rules like we know, right, if you want to transform each one of these points, our bed mass rules are going to say I have to take care of the multiplication first, and then the addition subtraction happen at the end. So therefore, what are we going to do with every one of these points? Every one of these points we're going to multiply by minus a half, and then we're going to add 1 to it. So if I were to take the first point 0 and multiply that by minus a half, and then add 1, you're going to go up to 1. If I take the point output of 1, so this point right here, and I multiply that by a half, it goes to negative a half, so it's down here, and then I add 1, goes back up to a half here. All right, continuing on here, obviously on the opposite side, you're going to have the same point. If you take a look at this point here, this is at a height of 4. If I take 4 and multiply by a half, you're going to get negative 2. Then if I add 1 to that, it's going to take it to negative 1. So this point is going to go right to negative 1, and likewise the other point will go to negative 1. So your quadratic here is going to look, as you can see, is going to look wider and is reflected in the x-axis and is shifted 1 unit up. So you have a lot here to describe. If I were to describe this transformation, you have reflection in the x-axis. You also have a vertical compression by a factor of 2, and we also have a vertical shift 1 unit up. So what we have here, these are the 3 transformations that we have with our parabola here. Okay, now let's take a look at number 13 here. So for number 13 here, we have a lot going on. So again, when you do your transformations, you do them by bed mass. So you're going to take care of your brackets first. So therefore, we have a horizontal shift of 1 unit to the right. Then after brackets, we take care of our multiplication division here. So that's going to be, that operation is multiplication. So then we have a reflection in the x-axis. And then lastly, we take care of our addition and subtraction. So in this case here, we have a vertical shift 2 units up. So therefore, every one of these points, we're going to shift it to the right 1 unit, reflect it in the x-axis, and then up 2 units. So let's do this point by point. So my first point here, I go 1 to the right. If you reflect something in the x-axis, it's already on the x-axis, so it's not moving, and then 2 units up is going to put me right there. My next point here, we go right here, we go 1 to the right. Reflect in the x-axis is going to knock it down to here. And then lastly, you go 2 units up, and that would be our point. Okay, so for the third point here, we're going to first go 1 unit to the right. So now we are here. Then we're going to go reflect in the x-axis. So this is 4 units up, so it's going to be 4 units down. So I'll put a little red dot there. And then we're going to go 2 units up, 1, 2. And there's our next point. And now continuing on here, the other ones are just a mirror image on the other side. So in this case here, our next point is going to be here. And our last point is going to be exactly, our axis of symmetry is right here for this quadratic. So they're one distance of 1 away. This is a distance of 2 away. So we're going to be right there. Connecting this up, we have our new quadratic here. Notice it's reflected in the x-axis. We have a shift 1 unit to the right, and then a vertical shift 2 units up. Okay, moving on to the very last question here. Again, B for brackets. So we're going to first have a horizontal shift 1 unit to the left. After that, we're going to have a reflection in the x-axis. Right, so this will be our first operation, our second. After that, we're going to have a vertical stretch by a factor of 2. And then the last operation is we have a vertical shift 3 units up. All right. We could, if we wanted to, do a couple of the operations, graph it, and then do the final transformation. So maybe let's take a look at that. Let's do these one by one. So for the first one here, I have a horizontal shift 1 to the left. So every one of these points, I'm going to go 1 unit to the left here. So every one of these points, I'm shifting over 1 to the left. So what I have here in purple represents my parabola just a horizontal shift 1 to the left. All right, so now that we've done that, let's take a look at reflecting each of these points in the x-axis. Well, if you reflect this point, it's on the x-axis, so it's not going to move. This will go down to the bottom. This will be reflected, right? This point here gets reflected below. This point here, right, is 4 above, so we go 4 below. And then likewise, 1, 2, 3, 4 below. So now this quadratic here is going to represent a reflection in the x-axis. So just to kind of see, just so everyone can see sort of what each of these are, my graph in purple would be y equals x plus 1 quantity squared. My graph in pink now is y equals negative x plus 1 quantity squared. Okay, now let's take a look at another one here. So now that I've done the reflection, I want to stretch by a factor of 2. So now everything is going to be multiplied by 2. So if you multiply 0 by 2, you're still at 0. If I multiply negative 1 by 2, you're at negative 2. So it's going to go down here. Likewise, this point is going to go down here. This point here is at negative 4, and if you double it, it goes to negative 8. So 5, 6, 7, 8, and 5, 6, 7, 8. So connecting this up here in green, right, we now have our quadratic in green here. And this would be the expression y equals negative 2 x plus 1 quantity squared. And lastly, let's pick our last color here. And I want to grab a plus 3. So you're going to take every single one of these points. You're going to add 3 units to them. So 1, 2, 3, 1, 2, 3, 1, 2, 3. And lastly, 1, 2, 3, 1, 2, 3. So connecting up this quadratic here would represent our transform quadratic. Okay, and let me write that one down for us. So putting them all together, we have y equals negative 2 x plus 1 squared plus 3. So you're free to do these. As you can see, I did these transformations one at a time, but if you combine a couple together, it declutters your graph a bit. So if you can do maybe a couple together, you eliminate some of the graphs. It's easier to see. Okay, at any rate here, we've covered all 4 of these transformations, and now we have our quadratic in black would be represented here. Okay, that concludes transformations. Please study these. It covers all types of transformations you would encounter. Again, you remember to do it using BEDMAS. You perform the operations of the transformations in the order of BEDMAS. So review this, go through them, and you'll be able to answer any transformation questions asked. Thank you.